everyone, we're going to identify and graph the polar equation r squared equals 9 cosine of 2 theta. This is going to be a Lemniscate, and I'll go over that in just a moment. Right now, let's use tests for symmetry to help us graph this. So the first test that we're going to do is see if our graph is symmetric with respect to the polar axis or the x-axis. And that's when you substitute in your theta with negative theta and see if you get an equivalent equation to what we have. So this is going to equal 9 cosine of negative 2 theta. Because cosine is an even function, we can change that to positive, so we're going to get r squared equals 9 cosine of 2 theta. So this test passes, and our graph will be symmetric to the polar axis, i.e. the x-axis. The second test is showing symmetry with respect to the line theta equals pi divided by 2. And that's when you take your equation and substitute in for theta pi minus theta. All right, this is going to equal 9 cosine of 2 pi minus 2 theta. Now, using your difference formula for cosine, let's expand that and simplify. So we're going to get 9 times cosine of 2 pi times cosine of 2 theta plus sine of 2 pi times sine of 2 theta. All right, sine of 2 pi is 0, so this is just going to be 0. Cosine of 2 pi is 1. So we're going to get this equals 9 cosine of 2 theta. It is an equivalent equation, so our test passes. So our graph is going to be symmetric both to the x-axis and to the y-axis. Therefore, we do not need to do our symmetry with respect to the pole. Actually, you could, if you substitute in negative r squared here, you're going to get r squared. So that's what that test is. But because it's symmetric to both of these conditions, then that means it's also going to be symmetric to the pole, the origin. Okay, for a Lemniscate, it has this form where A is positive, and this is like the shapes that you get. Not that one, that's a rose, sorry. So this is like the kind of shape you'll get. So let's assign values for our theta to be from 0 to pi divided by 2. And we're doing that because of our symmetry test here. We can, since it's symmetric to the x-axis and the y-axis, we can graph the whole thing just based off quadrant 1. So I have the values here, and let's substitute in. Now we have to solve for r, so I just took the square root of this. And remember, when you square root both sides, you need plus and minus. So at 0, we're going to have plus or minus 3. At pi divided by 6, we're going to have plus or minus 3 square root of 2 divided by 2. Now this is approximately plus or minus 2.1. At pi divided by 4, we're at 0. At these two, we're undefined. So let's try to graph this. Now we're at 0, we're at plus or minus 3. So here's your angle 0. Go out 3 both ways. 1, 2, 3. And 1, 2, 3. At pi divided by 6, we're going out 2.1 both ways. 2.1 here. And at pi divided by 4, we're at 0. All right, so that's going to be from here as well. So your graph looks like this. Since it's symmetric to the pole and to the x-axis and the y-axis, we can also assign values here. So for 5 pi divided by 6, we can also get 1.5. 2.1, sorry. 2.1. So a little bigger than 2 here. And over here as well. So over here we'll go 2.1. So the graph looks like this. And that's it. Thank you. Have a nice day. Bye-bye.